Dear all, welcome to the lecture series of Basic Electrical Engineering. In the last session I have discussed about analysis of AC circuit connected with a pure resistor, and we found that in AC circuit which is connected with a pure resistive circuit, pure resistive element, both the current and voltage both are in same phase. Here you can able to represent with the help of a phasor diagram. Here we are representing voltage across the resistor and IR is the current through the resistor. Both are in the same phase. It is a phasor diagram, rotating vector diagram or phasor diagram. You can see that from the circuit diagram we can able to understand that representing in the same phase. And also there is no phase difference. This diagram represents there is no phase difference because both are starting at 0 degree and ending at 2 pi. Okay, there is no phase difference between current and voltage. These are the basic observations which we made in the last session. While calculating the power, we found that power consumed, okay, total power consumed by the resistive circuit can be written as P is equal to Vrms into Irms. Okay, Vrms into Irms. Or else you can write in terms of maximum value also. Vrms will be Vm by root 2. Okay, Vrms is nothing but Vm by root 2 and Irms is nothing but Im by root 2. This can be written. Okay, Im by root 2. So these are the important observations we have already found in the previous session. Today we will be solving some numerical example. So an AC circuit consists of pure resistor 100 ohm and it is connected to an AC supply of 230 volt 50 hertz supply. Calculate the current, power consumed and equations for voltage and current. First you can draw the circuit diagram. So pure resistor which is having the 10 ohm and which is connected to the AC supply. Okay, so this is actually the current passing through the resistive element. So first you need to calculate the current. You can use the formula, then power and equations of current and voltage. Now let us solve the question. Very simple. So how to calculate the current? You know that current is equal to V by R. So you are able to get voltage is how much? 230 volt. Resistance will be 10. V by R. It is equal to 23 amps. What about the power? P is equal to Vrms into Irms. Okay, Vrms into Irms. So whatever the quantity they have given as Vrms only. So 230 volt means it is a Vrms. Remember this. Okay, whatever the quantity they have mentioned in the question, that is Vrms. So current whatever you have computed, that is nothing but Irms. 23 means it is basically Irms. Remember these things. Then your job will be easy. So P means Vrms times Irms. Vrms is 230, Irms is how much? 23. So you will be getting 5260 watts. Now you are asked to calculate the peak value. How to calculate the peak value? So peak value, anyway, if you want to write the sinusoidal equations, obviously you need to have a peak value. So Vrms equal to, Vrms is nothing but Vm by root 2. Vm by root 2. Therefore Vm is nothing but, Vm can be written as root 2 into Vrms. Root 2 into Vrms. Okay, this is a formula actually. Root 2 into Vrms. Vrms is already available, 230 into root 2. So it is nothing but 325.27 volt. Likewise, Im is equal to root 2 into Irms. That is nothing but 32.52 amps. Then one more thing is required. What is the equation, sinusoidal equation? V is equal to Vm sin omega t, correct? Vm sin omega t. And I is equal to Im sin omega t. Here Vm and Im are peak values of voltage and current, correct? Now omega to be calculated. Omega is nothing but angular frequency. Angular frequency is equal to 2 pi into supply frequency. That is nothing but how much? 314 radian per second. That is omega. So therefore we can able to write V is equal to Vm. What is the value of Vm? Vm is 325. 325.25 sin 3140, where I is equal to 325. Here 320. Im means how much? Im is equal to 32.52 sine 314 t. So these are the equations. Okay, I hope you understood how to solve the simple problem. So one more simple numerical example I will be showing you. So please read out the question. 100 watts PRMS equal to how much? PRMS equal to 100. Sorry, 1000 watts. 1000 watts. Heating element is to supply voltage is how much? 250. This is RMS only. 250 volt VRMS. Calculate the impedance. Okay, impedance is nothing but resistance, right? In pure resistive circuit, impedance is nothing but pure resistor. So R is equal to, how to calculate R? That's a question. Okay, and amount of current taken from the supply. So you are asked to calculate the impedance. Impedance is nothing but resistor. Okay, impedance is nothing but resistor. So you can use the formula. So PRMS is equal to P is equal to V into I, right? P is equal to V into I. Both are in RMS only. So from this relation I can calculate I. I is equal to P by V. P by V. So power is nothing but 1000. Voltage is nothing but 250. 1000 by 250 nothing but 4 amps. 4 amps. We are able to get 4 amps. Current is equal to 4 amps. So you need to calculate resistance. R is equal to V by I. You can use the formula. R is equal to V by I. So voltage is how much? 250. 250 by current. 250 by 250 divided by current is how much? 4. Then you will be getting the answer. Okay. Yes. Current is equal to 4 amps. Then resistance equal to 62.5 ohm. Okay, these are the values. Next, calculate the power being consumed by 100 ohm resistive element connected across 240 volt. So power being consumed by, you need to calculate the power. So power means P is equal to VRMS into IRMS. Let me write V into I. Correct? V into I. Then R is given actually. R is equal to how much? 100 ohm. Voltage is also provided, 240. So first you calculate current. I is equal to V by R. I is equal to V by R. Later you can substitute here. Okay, here V into V by R. You will be getting the answer. I is equal to VR by R, 2.4 amps. Then power is equal to I square by R, I square R. Okay, I square R, that is equal to 576 watts. These are the simple numerical example related to AC through pure resistor. Let me know if you are having any questions. And you can, if it is useful, kindly share with your friends. Finally, thank you very much for watching this video.